A big thank you to all my patrons who support the Engineered Mind podcast. Hi and welcome to the Engineered Mind podcast episode 65. In this podcast we cover topics such as engineering, AI, neuroscience, life, and other interesting topics and fascinating ideas to educate, inspire, and engineer people's minds all around the world. I'm your host Yusuf, and for this episode of the podcast, I'm very excited to welcome David Kopec to my show. David is active in the open source community as the author of several popular Swift data structure projects. He is the author of the Classic Computer Science Problems book series, which includes classic computer science problems in Swift, Python, Java. An avid podcaster, he has served both as a guest and host on multiple podcast series. A native of New England, David has lived throughout the United States, Canada, and England. He holds a degree in economics from Dartmouth College, as well as a Master of Science in Computer Science, also from Dartmouth. In this podcast, we covered classical computer science problems, David's book on these problems and why he focused on less than 10, frustration in programming, how to become a better programmer, books and the difference to classical teaching, tips for young programmers or beginners, and much more. For updates on upcoming podcasts, projects, and videos, make sure to follow me on Twitter as well as on Instagram. To join my weekly newsletter, engineeredmind.sh, where I share exclusive content, visit yusuf.substack.com. And now, ladies and gentlemen, here's my podcast with David Kopec.
I'm really excited to be here. I've been listening to a few of your past episodes. It's really an honor to be on with you.
Awesome. Today we want to talk about computer science problems, especially the book that you have written about these computer science problems in particular. So talking about genetic algorithms in general, and all kind of other problems. Maybe to directly, or before we directly jump to the book, maybe give us like a 1 or 2 minute bio. Who is David?
Sure, yeah. So I'm 34 years old. I'm an assistant professor of computer science at Champlain College in Burlington, Vermont. I worked as a software developer for a few years before going into teaching. I really got into computer science education because I wrote my first book, Dart for Absolute Beginners, back in 2013. I wrote it, came out in 2014. And that kind of led me to then try doing some teaching on the side as I was working as an iOS developer. And eventually thought, wow, I really enjoy this. And I got a full-time job as an assistant professor up here in Vermont. And I've been here now for 5 years, more than 5 years. And I've written 3 books in the last few years on computer science problems for a technical audience. They're intermediate level programming books. The first one was in Swift. The second one was in Python. And the third one that just came out a few months ago was in Java.
Mm-hmm. That's great. Why did you even decide to write this book in the first place? Why computer science problems? Why is it so essential to learn about these kind of topics?
Yeah, I went on kind of a zigzag route. So my first book that came out way back in 2014 was a beginner's book. It was Dart for Absolute Beginners. The idea was when someone is learning programming for the first time, maybe they want to use this new language, Dart. Now, Dart at the time didn't really take off until Flutter came out many years later. So you could say maybe the book was ahead of its time. But then when I was thinking about the first book in this classic computer science problem series, my goal was to write an intermediate level book in Swift. Swift at the time was pretty new. Swift came out in 2014. I was writing the book in 2016, 2017, and there were a lot of beginners books about Swift, but there weren't a lot of intermediate level books. And both of these were like languages I was excited about. So I was excited about Dart when it came out, and then I was excited about Swift. So I was like, okay, this time I'll try to write a book that's a second level book. That's a book for people who already have some knowledge but want to kind of take it to the next level. And what I noticed is that there's a missing category of books for people who don't have a computer science education and want to learn some of these computer science topics. So maybe they're a programmer, but they never got that computer science education. That doesn't mean that students don't read these books too, and they're not sometimes used in classrooms, but they seem to serve a lot of people who are self-taught programmers. And they might be good programmers and they just want to get deeper into some of these topics they've heard about, like you mentioned, things like genetic algorithms. What is that? How could I use that in my programs? Should I use that in my programs? So getting some deeper knowledge in this more formal area of computing. And so I wrote the Swift book, and the Swift book, it did so-so, but the publisher said, we think you wrote a good book. We should bring it to a larger audience. And I've also done a lot of work, both professionally and also in my teaching in Python. So Python was the obvious language, and there's a lot of self-taught programmers in Python. So we brought the book over to Python, and that came out, I think, 2019. And it just did really well. It really took off, and it's been very successful. And then we thought, okay, let's bring it to another big language audience since it did so well in Python, and that's how the Java book came about.
So when I have a look at the book, like in the all of the chapter or table of contents, we can see things like small problems, search problems, constraint satisfaction problems. So there are, let's say, 7 or 8 topics or 9 chapters in total. Why did you decide for those chapters? And do you think this is like the essential bundle, so to speak, if someone gets your book to learn about?
Yeah, that's problems? A great question. When people go and they say, I want to learn computer science, what they generally go and learn is data structures and algorithms, which is kind of at the core of computer science. And if you take computer science in college, that's going to be the second, third level class that you take is going to be a data structures class, an algorithms class. Sometimes they're combined together as one class called data structures and algorithms. There's a lot of great textbooks in that area. The problem is, if you're a self-taught programmer, this is what I found. A lot of people find that content very dry. They find it very, very hard to get through, very formalized. It requires a certain level of mathematical maturity. I wanted to write a book that was more gentle. I also wanted to write a book that was about topics that were a little bit more exciting in some ways than what you get in your typical data structures and algorithms book. So this is definitely not a textbook. This is definitely not a book that's going to give you, the formal knowledge to go on and be a computer scientist. This is a book that's going to introduce you to a large range of topics in, frankly, a kind of shallow way. It's a very broad book. It's not a deep book. You're not going to be an expert on neural networks after you read the neural networks chapter, but you're going to know enough to know what it is, when you should use it, how it works a little bit beneath the surface. It's very code centric, very tutorial like. So we kind of walk you through step by step. This is how we could build a simple version of this problem solving technique. And by the end of the chapter, you're going to be able to build it yourself. But again, you're not going to have a deep knowledge of it, but you're going to understand how it works beneath the surface when your colleagues, if you're working as a programmer, talk about, hey, maybe we should use a constraint satisfaction solver here. You're going to know what that is and what are the pros and cons of using it and how it might be able to solve the problem that you have right now. So to answer your question, the reason I chose these chapters is because I thought they were engaging. I thought they were a good broad survey. I thought they gave people an introduction to a lot of different problem-solving areas without getting into the weeds of some of the more dry topics. Like, I'll just give you an example of what I mean by the dry topics. And there's nothing wrong that these are in there. I teach data structures and algorithms classes and go over these. But oftentimes in a data structures and algorithms book, there's going to be a chapter or 2 or more on sorting. And sorting, it's the way that you solve it algorithmically is kind of interesting. But after you solved it in some of those books, 3 or 4, sometimes 5 different ways, people will start to zone out a little bit. And especially if you're teaching to a self-taught audience, as I am a lot in these books, I don't want to get down and start boring people. So I move quickly from one chapter to the next to different kinds of problem-solving techniques, giving you enough to understand why they're useful without getting down into the weeds of any of them.
Mm-hmm. For example, you talked about a few chapters in your book. Why people might ask, okay, why do I even have to learn about these classical computer science problems? Sounds a bit like a waste of time. Why would I even consider learning that?
Yeah, so the right one to pick to solve the problem at hand. So I'll give you an example. Maybe you're working on an app for a bookstore, and you have a lot of different inventory and a lot of different customers. There's a lot of data you're going to be generating. And maybe you want to build a component for the website that's going to help customers figure out what book they should buy next. Well, which problem-solving technique do you reach for to solve that? There's many different ones you could use. Maybe one of them, I'll just give you an example. Maybe you're using a neural network to make predictions about it. That's not necessarily the right one. I'm just using it as an example. You're not probably going to go build that from scratch. You're not going to go build your own neural network like we do in the book from scratch. You're going to go reach for a library. But how did you even know that you should go use TensorFlow or whatever library you're going to use? How did you know that that was the right technique and the right problem-solving solution to make those predictions? By reading this book, you're going to know enough about those different problem-solving techniques to know which one to reach for, and you're going to feel a little bit more confidence too, knowing how they work beneath the surface. So it's not about that you're going to go reinvent the wheel as a programmer, as a software developer, and go implement all these techniques every time you need to. It's about knowing what they are, knowing enough about them that you'll feel confident choosing a library. And it's about having that wealth of knowledge so that you feel like you didn't miss anything when you didn't maybe get that formal degree. Sometimes when people have that formal degree, they still find this book useful as a refresher, as an accompaniment. Sometimes people use it when they're reviewing for interviews, so they're getting ready, for a technical interview. Sometimes I've heard people have used the knowledge in these chapters to be able to pull out the right answer in one of those technical interviews. So I'm not saying that they're only for self-taught programmers, but it's filling in knowledge gaps and knowing then what to reach for, what library to use, what technique to use.
Yeah, and all of those years that you've accumulated your knowledge and taught people basically how to program or solve computer science problems, are these topics in the book the ones where you say, I would say these are the most important ones, or is there more to it? What would you say?
Yeah, it's interesting because when you're writing a book like this, like I said earlier, you got to balance between engagement and knowledge depth. And so some of the topics, I'll be frank, are not the most useful topics for most programmers. I'll give you an example. You mentioned earlier genetic algorithms. We do have a chapter in there on genetic algorithms. They're not really something you're going to use that often, but a lot of people find them really interesting. So I included that chapter because people find them interesting and because, frankly, they're not that hard to implement. So it was also a nice kind of middle of the book kind of chapter before we got to some of the harder things. But on the other hand, some of these techniques are extremely essential. Like chapter 2, we go over search techniques like breadth first search, depth first search, the A-star algorithm. You're going to use those all the time as a programmer. Those are really common. You think about if just give you an example, if you're going to work in game development and you're going to be figuring out paths on a map for a character to traverse, you're going to probably use something like the A-star algorithm. So it's something that's going to be really relevant to that. But it's also something that you might use if you're working on transportation networks and you need to figure out how to get from one point to another point. Or it might be something where you're searching through a problem space related to a data crunching problem. So there really are a lot of areas that you can use search algorithms. So that's like a super essential chapter. But then we also have these kind of more just they're interesting type of chapters like genetic algorithms.
Mm-hmm. This is so interesting, David. When it comes to like all the programming problems in general, where would you say people should maybe start? Is this a book that you can start from the beginning and read it through the end, or you just pick one topic and then you can just choose what you basically like?
That's a great question. I do think it's good to read it from beginning to end because it does kind of go from easier to harder. And then there are some points in the later chapters where we refer back to the earlier chapters. Some of the chapters are actually a lot of the chapters are pretty standalone. So you could pick it up and kind of go to a random chapter in the middle. What I hear from the books had really good reviews, but what I hear sometimes from people is they're kind of like, they read the first chapter and they're kind of like, this is too easy. And they kind of give up on it. That's something that's happened a few times. And, the first chapter really is supposed to be easy. It's supposed to be really gentle. And I did that purposely to kind of draw people in, but maybe it feels a little out of place. We named the first chapter Small Problems, and it really is these really simple, not hard to solve problems. So I think if you're finding the first chapter too easy, just skip over it, and just go to the second chapter and go from there. Because most of the chapters, you don't need any of that knowledge from the first chapter. It was supposed to just be this gentle kind of, getting people into it sort of thing.
Yeah, I had a look over your book and I must say, really, if you need something or delve into classical computer science problem, I think your book is the way to go because you have everything very compact in a nice book format. But now the question arises, book versus courses. Where do you see the advantages of books versus maybe teaching on-site or giving courses online?
And thanks for your comment. I appreciate that. So I think obviously I teach courses, as a professor, so I'm a little biased in that I think there's a lot of value actually to formal education and to taking classes. That said, different people are different kinds of learners. Some people are more visual learners, and they're going to really benefit from watching a YouTube video. And some people are better, they retain more information from reading. I think what you get out of a book like this that's very code-centric is if you're somebody who likes, and I'm kind of like this, I like to learn from code, getting that combination of the code with the commentary right next to the code is really beneficial to people like me who really do learn well from code. But it requires that already, like I said, that you're an intermediate or advanced programmer for it to be worthwhile to you. But I think it really can serve as a good adjunct to doing a course that covers some of these topics. So maybe you're taking a data structures and algorithms course, or even an introductory artificial intelligence course, because we have a lot of artificial intelligence type chapters in the book. And you use the book as a supplementary piece of material to go along with that. So I think if you're a self-taught programmer and just wants to kind of know what these topics are about, just reading the book is great. But if you want to get a more formal knowledge of these topics, the book's not going to be enough. It's too shallow. It doesn't go in depth into any of the topics. It just gives you a basic introduction, shows you how we can implement it, gives you some information about how those topics are used in the real world. But it doesn't give you a knowledge where you could say, well, I read class computer science problems in Python, and now I'm an expert on neural networks. Nowhere close to that. In fact, you'd have to take many classes before you can do a lot of implementation before you'd feel like an expert. So if you want more depth, I do still recommend, a formal class. Absolutely.
This is great advice, David. And I wanted to ask this as the next question. What does David Kopec do to basically educate himself? Like, do you go on Twitter, look at some tweets, interesting tweets? Do you follow specific people? Do you read blogs, newsletters? What do you personally do to keep yourself up to date?
Yeah, what's been really helpful to me over the past almost a decade now is I've been pretty active on Hacker News. And I do read formal academic papers, I do read books and all that. But when I'm keeping up on kind of what's in the zeitgeist in programming right now, what's going on that's exciting right now in new developments, I really would say Hacker News has been a big helpful piece for me. In terms of keeping up my own knowledge, I do a lot of open source projects. I do a lot of just on my own building things. And I think it's important if you're working as a teacher, teaching computer science, to stay an active programmer yourself. And, there's a little bit of many different sides to computer science. There's the very formal side, people who do algorithmic work and do the real mathematical side as well. And then there's also the programming side. A lot of what we're building when we get a computer science degree is work towards having a career as a software developer. That's what 80 to 90% of people who get computer science degrees end up doing. A lot of them don't end up doing that formal work. And I think it's important, if you're teaching computer science, to be in touch with the software development world so that you're bringing in what's really happening in industry into the classroom. And you're not just talking about, theory, and not just talking about what frankly is important, but not what most people are going to be doing. So I always try to keep one foot into what's going on in software development. I do open source work. I build some apps myself, and I do just some projects for fun. One thing that I've been getting into that I didn't have a lot of experience in until a couple of years ago, and now I'm getting more experience in, is emulators. So I've been just on my own, just for fun, building like a Nintendo emulator, an NES emulator, building an original IBM PC emulator, and just trying to get more experience with kind of those low-level sides of, let's say, working with the C and C++ languages that when I was working as a software developer, I never got a chance to do. So I always try to stay fresh. I always try to just keep experimenting on my own, and I hope that I'm bringing that into the classroom.
Yeah, I love that you mentioned this, David, because real life experience is something completely different than having the theory in mind. What would you say? Let's say I have your book, I read about genetic algorithms, let's say, for example, and I want to build something with that knowledge. What would you recommend if someone has your book and wants to actually build something with it? Where should they go? What resources should they?
Well, I'm going to cop out on that question a little bit, because I think that you have to do things that interest you. So you read the genetic algorithms chapter, and you maybe are interested in, and I don't know if this is any specific person, but you're interested in maybe seeing how you can build a kind of evolution simulator, kind of like the game Spore or something from the early 2000s. If that's what excites you, that's what you should do. What I think one of the biggest issues we have with students today is attention span. And I think, I'm pretty young as an instructor myself, right? I'm in my 30s. But I think that even just since I was in college to today, there's really been difficulties with attention spans. And I think it's happened as a result of social media. I think, there's a lot of people studying this. I've seen some papers, I've seen some documentaries about it. There's a lot of evidence. Maybe it happened when the smartphone revolution came about. But whatever it is, it's hard to keep people engaged for long periods of time. And I think the only way to get over that hump is to really always be doing things that you're interested in. And so I'm not the type of person who tries to be prescriptive and say, here's the exact project you do. Sometimes you'll see articles online where people are recommending, oh, you're getting into programming. Here's all the projects you should do first. I don't believe in that. I think you should dive into whatever interests you and just keep practicing. Like anything else, programming to be a better programmer, I think is all about practice. It's just like learning a human language or learning a musical instrument. And so the only way you're going to keep practicing is if you're having fun and you're being engaging your mind as you do it. And so to tell somebody, here's the project you should do, I don't think that's always the most helpful thing. When they read one of my books, they're going to get introduced to a whole lot of different projects. And they're only going to spend one chapter or half a chapter with each one of those projects. So hopefully it's not long enough that they're going to get really tired out by it. But then after they're done, they should really just go in whatever area really just engages them and gets them excited. I don't think there's a specific way that you should say, this is the project you should do next necessarily.
Yeah, I love that advice. How do you personally tackle frustration in programming?
Well, you do need a certain amount of resilience as a programmer because I've had, and this is embarrassing, but I've sometimes spent a whole day tracking down a problem in a large code base that was just a comma that I misplaced somewhere and didn't realize, and that might be because I don't use the right linting tools, or maybe it's that I wasn't being enough a perfectionist when I was writing it in the first place. But most people who've been programming for a while, I think, have experiences like that. And it can be extremely frustrating, and it can really be very demoralizing on top of being frustrating. And I hate to say this, but I don't always get that big. Some people say, oh, when you finally track down that bug, you get this big bit of satisfaction when you found that problem. If it was a complicated problem, I think you feel that. But when it was a comma that you missed somewhere, I don't think you feel that. I think you just feel a little angry at yourself, or maybe a little bit like, why am I doing this? Is this a good use of my life? It only comes with, I think, experience and time that you kind of get over how frustrating that can be. But you need to, like anything in life, it doesn't come without some work and some unfortunate times. You got to kind of push through those times to get to the point where you feel like you're building things that are significant. But when you first do that, I think I've gone on kind of a tangent, but when you first do that project that goes from being a few hundred lines to a few thousand lines, that's when I think you start really having these experiences where, it starts to be, the project's large enough that when you reach a problem, you don't know how to solve it right away, and you can't figure out where it is. And you're using all the tools that you have available to you, hopefully. Hopefully you're using your debugger, you're using logging, you might even be using some more advanced tools like a Valgrind or something like that. But you're using these tools and you're still not solving it, and you get really, really frustrated. And it's not going to feel good when it ends up being that comma. And you just have to kind of accept. I think a big part of being a programmer is accepting that there is going to be times like that. And the tools that we have, unfortunately, are not yet at the level where they can remove all of those frustrations. So I think acceptance and building resilience over time is the only way to be okay with it. But it's unfortunately, there's no solution to that right now. Yeah. I hope we'll have better tools in the future, but there's no solution to that right now.
Yeah. So on one side, we have having to accept basically the frustration which comes with programming, but on the other side we have the love for programming. Why does David, or why do you personally love programming? Why is it so fascinating for you in the first place?
I love problem solving. And, some people are in this field because they love the code. And some people are in this field because they love what they can do with the code. And I'm more that I love what I can do with the code. I like coding, I enjoy it, but I like even more what I can build. And I think there's no other field, at least that I know of, and I'm not an expert on everything, but from what I've seen in my life, there's not a lot of other fields that give you as much leverage, where a single person can actually produce something that's going to be pretty world changing. I mean, you think about some of the big companies today in the tech field, and a lot of them were founded by a small group of people. We're talking about a few people. You think about something like Facebook, Google, or even Apple, right? The Apple was Steve Wozniak basically created the Apple One, right? Now that's more hardware side. He did some software stuff too. But or you think about Sergey and Larry building Google. I mean, that was their PhD thesis. And then they built the systems as a result of that with not that much help for the first version. Or you think about Mark Zuckerberg and a few other people building Facebook. I mean, these are world-changing institutions, world-changing pieces of software or computing devices that were built by just a few people. I don't know how many other fields that amount of leverage is possible, that just a few people can build something so important or that has such an impact. So I think that's really exciting. And I hope that the people I'm teaching are going to be some of the people who are going to build these next systems.
Yeah, this is nice that you mentioned. So is one of your motivations to actually teach people that hopefully, are you satisfied by seeing people succeeding by reading your book, for example?
Yes, absolutely. I mean, that's the motivation, I think, to be a teacher. I like teaching. I enjoy lecturing. I enjoy, working with students on projects. I enjoy writing. But I think what really makes you feel good at the end of the day is seeing what people do after they read the book or took the class with me. So whether that's the job they got or the piece of software that they built or the career that they had. I think over the last 5 years of working full time as a teacher, I've started now just in the last couple of years. There's students who I started with 5 years ago, who graduated last year, and some of them, we were a small college. Some of them took an absurd number of classes with me. There was somebody who graduated last year. There's more than one person actually who took 6 or 7 classes with me, which is just crazy. I can't imagine that from when I was in college to take 1 out of every 6 or 1 out of every 5 classes with the same person. But we're a small college, and I happen to teach classes, first-year classes, second-year classes, third-year classes, and fourth-year classes. And so I had some students who went through the gamut with me. And it's been incredibly rewarding seeing them get good jobs or seeing them build that first, a couple of them have built some open source software after they've graduated. And seeing them do that has really been really gratifying for me in a way that I didn't really realize when I was starting. So I love the question you asked because, yeah, for me, a lot of the motivation does come from seeing what people do with the knowledge that they got either from the class or from the book.
Yeah. Where do you get your motivation from? Do you personally have someone you're looking up to, like in terms of programming, someone that inspires you?
Well, I think there's a lot of people that I admire as programmers. Certainly Peter Norvig and Paul Graham would be 2 people that have been inspiring to me over the years. They're kind of like celebrity programmers, but they're certainly people I look up to. But I wouldn't say that, unfortunately, I think it's kind of been sad for me that I haven't had exactly like a programming mentor over the years. I would have liked to have had that. I would have liked to have had somebody in person that I knew that's really been maybe a partner or maybe just a mentor and somebody that I've learned a lot from, because I have done a lot on my own, really. I think it's something that's, for me, is a lifelong passion. Like I started programming, and this is kind of a stereotype, right? But I started programming when I was 8 years old. And so now it's been, 26 years of programming. So it's something that's been with me since I was a little kid, and I never really stopped and said, why am I doing this? I just kind of kept doing it over the years because I've always been excited about building things. Like I said before, about what's the software you can make. And I like to think that I'm still kind of going towards a point where I'm going to build some really interesting piece of software. I've built all kinds of different software over the years, nothing that's been world changing or even had what I would call a large impact. So I'm still, I'm still a dreamer, and I still like to think that someday I'm going to build that incredible piece of software that's going to have a big positive impact. But I like to think that I'm working towards that, maybe, and now for the tech industry, I'm getting kind of old, because they say for the tech industry already in your 30s, right? But I like to think that my best programs are still ahead of me.
Oh, this is beautiful that you mentioned, Dave, because that would have been my next question, actually. Do you work towards like an end goal, or is this concept of an end goal, is it like kind of an utopia, like it doesn't exist for a program? Because you have so many things that you can build, but reaching the end, basically, you only have one life, and one life isn't enough to build everything, basically. How do you personally see it? Do you live in the here and now? Kind of a philosophical question. Do you live in the here and now, or do you want to accomplish as much as possible as a developer?
No, I would say I am kind of a dreamer, and I'm not satisfied with where I am right now. I'm never satisfied with kind of my abilities as a programmer. I don't think you need to necessarily be the most incredible programmer in the world to be a good programming teacher. Because the thing is, when I prepare my book, right, I get to work on that for years. I can spend years perfecting it, getting it to the point where I really feel the code is the most understandable and the most elegant way to solve the problem. Same thing with my lectures. When I'm preparing for school, I might give a lecture that is an hour long. I might have prepared 20 hours to give that 1 hour lecture. So you really can spend a lot of time getting things to the point where they're really in the perfect form to be taken in by the students. But on my own programming, I'm really not satisfied with where I am. I want to be much better than I am right now, even after doing it for 26 years. And I still think I am improving. I think I'm getting better, every year. I think that the level that my programs are at now at 34 versus where they were at 24 is kind of night and day. And so I still think I'm getting towards that point where I'm going to build that really great piece of software. So I'm a bit of a dreamer. I'm not living in the here and now, and I'm not satisfied with where I'm at right now.
Mm-hmm. Beautiful answer. I love it. You also work on other projects by yourself. For example, you have a podcast and several other things you're working on. Maybe you can give us a little bit of insights what you're working on at the moment.
Yeah, sure. So I do have two podcasts that I co-host. One is called Kopec Explains Software, and we talk about software concepts for a general audience. So it's not really for programmers. It's more for people who just want to know more about computing. And then I also do a podcast called Business Books and Company with a couple of my friends. We read a business book each month, and then we talk about how it has impacted our careers, what we learned from it, or just general ideas from the book. So those are the two podcasts I do. I also run a daily newsletter for where I live here in Burlington, Vermont, called BTV Daily. And it's just like every morning people get a rundown of what's going on in the Burlington community. It's mostly auto-generated. I wrote a Python program to make most of it. So it's pretty low maintenance, but it is growing. We're a small city. Only 40,000 people live in the city, but we have about 500 subscribers. So we're already at, what is that? A little more than 1% of the population is already reading our newsletter. So we're growing, and we hope to get to the point where we can have some advertisers in the newsletter and really be more significant. So it sounds pretty small right now, but it's a small city. So yeah, those are just kind of for fun projects. And then I build some apps on my own that I'm not that proud of, but they sell a few thousand copies here and there. So that's just kind of a side thing to keep me fresh. And I'm always working on kind of new app ideas. Right now, me and my wife, and actually my mom too, we're working on a little business idea of creating custom flashcards for babies. So you're going to go to our website, you're going to create these flashcards using your own photos and whatever you want the words to be on them, and they're going to be really beautifully printed, and packaged in a really nice gift-like way. So it could be a nice gift for a person with a young child, or they could maybe be something you get for your own child. So that's just kind of like a side. These are all these side projects I have.
Very, very busy day. To kind of wrap things up, is there like a kind of a general question? If you have 3 advices you could give to your younger self or people starting out with programming, what advices would you give them?
I'll choose to young people starting out in programming instead of myself. So the first one I would say is practice, and we talked about this earlier. But like in anything, programming is something that you're not going to get overnight, anything worth doing at least, right? It's not something you're going to get overnight. You're not even going to get it over 1 month. It's going to take a year or more of practice before you feel like you're really getting somewhere where you can build something cool. So you got to keep at it and not give up and keep practicing. So that's my first piece of advice, practice. Second piece of advice is to do projects that interest you. So, and we also talked about that earlier, but really dive into things that are going to keep you engaged, because it's easy to lose interest if you're doing things that are boring. And we all struggle, I think, and I feel bad because earlier I kind of put it on people just a little bit younger than me, but I think it's all of us. We all struggle with attention spans today. We all have constant distractions. And you got to do things that actually interest you in order to not get distracted, unless you happen to just be blessed and you can just power through. And then I'd say the third piece of advice I have is to not be, and this is one that's a little different, but don't be changing languages too much when you're first learning. There's a lot of people when they're first learning programming, they start thinking, well, maybe I'm not learning the right language. And they change. And they say, maybe that's the reason I'm having roadblocks, is I'm doing JavaScript and I should have been doing Python. Or I'm doing C++ and C++ is too hard. I should be doing Python. Sometimes that's true, but the vast majority of the time, it's better for you if you stay in the same language for the first, let's say, year or two. Really become really good at one language, then branch out, and you can do whatever you want. Once you know the basic concepts in one language, they're going to be transferable skills as you learn other languages. Even though the languages might even look quite different. But once you know Python, you're going to know something about object-oriented programming. And then if later on you learn C++, even though they're very different languages, you're going to be able to transfer some of that knowledge. You're definitely going to be able to transfer knowledge about loops and if statements and things like that. So it's really important, I think, to not jump around too much during the first year of learning. Just stick with that first language, even if it's not the perfect language for whatever you wanted to do. If you're already into it, you've already spent some time on it, I would stick with it till you become competent in it. Once you're competent in that first language, then feel free to branch out as much as you want.
Yeah, that's beautiful advice. And I catch myself there because I learned MATLAB when I was studying mechanical engineering. And then I thought about, do I start with Python, C++, or like Java? And I was like jumping back and forth. And you're absolutely right. It doesn't make sense to jump back and forth here. David, I enjoyed the podcast so much. Is there any, or are there any last words from your side? Now's the time to do so. And then we wrap things up.
Well, I want to thank you so much for inviting me. You know, it's an honor. I know I've actually been on the podcast with some of your previous guests. And so to be amongst them is actually really an honor. They're really incredible people. I am going to do a little self-promotion because, you know, they say if you're not, you know, for yourself, who is, right?
Go for it.
My latest book is the Java book. So if we have any Java programmers listening, it's Classic Computer Science Problems in Java. And it just came out a few months ago. So it's fresh off the press. And I think it's actually the best of the 3 Classic Computer Science Problems books. But sorry, had to put in a little stuff. You know what? I talked about you asked me great questions and I talked a lot about myself. So now I feel kind of bad doing that at the end. But anyway, I do think I stand by my products. I think it's a great book.
Yeah, I think so as well. At least I had a look at the Python one and I really, really love it and how you have written it. One last question before we really wrap things up, because you mentioned the Java book right now. And of course, I will put the link to all of your books down in the description with a discount code. Why Java and not another language?
Yeah, that's a great question. So Java was one of my first loves as a programming language. I learned Java when I was 12 years old. I started learning it in 1999. And so it's kind of been going in and out of my life. I was learning it as a teenager. I did a lot of projects. Some of my first real programming projects were in it. And I learned BASIC before that when I was even younger. But so Java was a big part of my life. I did a startup where we were using Java when I was in my 20s. Then I kind of fell out of it again. And then we use Java as a teaching language in some of our classes. Like I used to teach Android development in Java. We recently moved to Kotlin, but we have some other classes in Java as well. So it's kind of been going in and out of my life. And it was actually a big debate with the publisher. What language book should we do next? We had done Swift, we had done Python, and we put a poll out amongst readers. And we actually had hundreds of people vote in the poll. And the 2 languages that were at the top were Java and Go. So that was a part of it. And actually Go won by a little bit. It was really close. And the thing was, my background was more in Java. So when I write one of these books, it has to be a language that I'm like deeply into. I can't write a book about Go. Not, I've used Go, and I've actually read a couple books on Go, but it's not like a language I'm deeply in. I haven't done big projects in Go, whereas I have in Java. So it has to be a language that I'm passionate about, or at least I have a deep knowledge of. And Java fit that bill, and it was close to the top, so we went with Java. But there's been talk like, what are we going to do the next book in? Because now that we've done this book in 3 different languages, and it's also been translated into 8 different human languages, the Python one, which has been particularly successful, you start getting questions like, okay, are you going to do C# next? Are you going to do Go? Are you going to do Rust? Like, what's it going to be? It's hard because I'm running out of languages that I'm deeply like intimate with, right? Like Python, Swift, Java. Yeah, those are all ones that I've done some big projects in. I know a bunch of other languages, but they're not ones where I feel like as an author, I can speak to you super confidently in. So will it be that, if the Java book does well, we'll do another book and we'll get a co-author? That's possible. Maybe we'll find somebody else who's really a Go expert, and they'll help me write the Go book. But I like to do these books on my own. So it's very possible that until I end up getting really deep into another language, that we won't have another book. But thanks for the question, though. It was an interesting kind of road to figure out Java.
Mm-hmm. Thank you so much, David. I really much appreciate your time being on the show. And we talked about so much, actually, in some things in detail, some things only scratching the surface. But maybe, who knows, there will be a second part in the future talking about classical computer science problems in Go. Who knows? Yeah, with that being said, thank you so much, David, for your time. And I'm looking forward to see you in the second part.
No, thank you so much. I really appreciate being on.